Okay, so this video we're going to go over how to 3D model in Rhinoceros. And this is just going to be a very general commands kind of video. It's not going to be the more in-depth stuff just yet, but that will be coming up. So we're going to go off in a totally blank large-scale template, feet and inches in Rhino. I'm just going to show you some basic tips of how to model in 3D. I'm assuming at this point that you already have worked in drafting and have that nailed. If not, a lot of the commands we will use will actually carry over for that. So I'm going to start by drawing a simple two-dimensional drawing and convert that to a 3D object for you. So I've picked my line tool up here. You can also type in line or polyline up at the command bar. The command bar we will reference many, many times just because, at least for the Windows version, this is how it would look. It's very helpful for telling you what the step that you are on and for actually knowing how your commands work if you've never used them before, or if you're just not familiar with this program, or if you're coming back to the program and you need to a refresher. So notice my settings here at the bottom. I've got grid snap turned on. I may turn that off. I'm not huge on using grid snap, but in this case it might help. Orthographic turned on. They'll keep everything 90 degree. And O snaps are turned on, and these are over here are my O snaps. You can see I have endpoint, near, mid, intersect, perpendicular, and quad turned on. I'm going to go ahead and turn off intersect right now and near for the time being. I might turn those on later on. Center I use too, but okay. I'm going to switch my view real quick before we even start to ghosted. I recommend this very highly because it's going to make, and I'll show you why in a minute, but it'll make your 3D model much easier to work with when you work out of ghosted. So now that sets this perspective view to ghosted. It doesn't change your other views. My top view will be still in wireframe or whatever the default is. All right, so I've got my line still, even though I've messed around with everything else. I still have my line command open. That's one of the things I really like about Rhino personally. I'm going to type in 0, enter, and that sets my first point at the origin point. I'm just going to go 10 feet in the Y direction, click, and it's still a polyline, so it's still able to make more lines until you make the line a closed shape. So we're going to go now 15 feet in the X direction, and then 10 feet back. And notice whenever I type this in, it's showing up on the command bar up there at the top, and I'm typing in feet with the little feet symbol instead of the inch symbol, which would look like this. We're going to switch that to feet, and then I'm going to click in the direction that I am applying that distance. Now it didn't register that that was 10 feet, so I'm going to click my little pointer tool, and notice it got rid of it all, and that's okay because it's not going to slow me down very much. So 10 feet, click, 15 feet, click, 10 feet again, click, and then I'm going to close this off by just selecting the origin point. You could also, I think, I'm not sure if it's also just in Rhino, but I know that in AutoCAD, you can, and a few other programs that you can just type in C, enter for close, and it'll close that shape. But that's not important. This video is just to show you tips and tricks that will help speed up the process of modeling. So I'm going to now turn this shape into a plane for you. So I'm going to do that by selecting it, typing in planar surface, and it has to be spelled that way. But if you do not know how to spell it, or if you can't remember, you'll notice once you start typing it in, it brings it up, and a bunch of other options that are close. But planar surface is the command that you're going to need to know. I'm just going to hit enter, and immediately I can see this. I'm going to pan around. Notice that one side is lighter than the other. I prefer to see this side, the light side facing up. So I'm going to type in flip while I have it selected. Now it is facing up. You can use that command whenever at any point and it'll help just as a preference. Notice the color is going to be the same color as whatever layer this is in. So if I move this over, if I go to the properties while I have it selected and I move this layer, this object to the layer 1, it will make it red because I have my layers set up so that layer 1 is red. If I change that to say gold, it is now gold. Everything in that layer will be gold. It just helps you to distinguish what is in what layer and what material it is if you have it based on material. If I make layer 1, if I rename that and say I renamed layer 1 to be concrete, now I know that everything I'm going to be making out of this would be concrete. Or if I'm going to do it differently, say I want to organize it by, say I want to do it by a line type. So if I'm going to make this contour lines, then everything in that layer would be contour lines. Right now I'm just going to keep it as layer 1 as generic because this project is not going to have very many specific details. It's just a demonstration. So now I'm going to take this surface and turn it to a three-dimensional object with a command called extrude. Notice that it says curve on the end, CRV. That would be for extruding a set of lines, but we are not doing that. We have a surface selected, so we're going to do SRF for surface. Now you can see that it's wanting to extrude this. I can set the distance now. It's saying right here in your commands, extrusion distance, and it's asking for that. Right now it's set at negative 1.5, and that's going to be negative 1.5 feet. I don't really like that, so I'm going to type in my own distance. I'm going to set it to 10 feet. Enter. And notice that it did it in this direction. It already placed it. It's not like the line tool. Had I did it this way, where I type in extrude, and notice how it already remembered that I used ExtrudeSrf before, so it's using that as its default. It'll use whatever command you've used the most whenever you're searching for commands. Now if I do it in this direction, and I type in 10 feet, it still does it in the positive direction because it is a positive. If I do it with a negative, so negative 10 feet, then it will go in the negative direction. Let's get rid of this. Now, here's the thing. Do not be fooled. This is not a 3D object yet. It is still a set of planes, but they are all connected. One way I can make them disconnected is by selecting it, and notice it calls it, whenever I click on it, there's multiple options here. They're both poly surfaces, and that's because there are two on top of each other. So I'm going to get rid of one, and now it's just one. The only reason why there were two on top of each other is because I did the command twice. So human error, and that will happen, so don't be fooled. But do not be fooled, this is not a three-dimensional object yet. It has no end caps. The way that we make it a three-dimensional object is simply by typing in the command cap, hitting enter. Now it has the top and bottom sides. Notice that it is completely separate from the original surface. So let's go ahead and delete that surface. We no longer need it. A quicker way to make this object, I'm going to take my original curve, and it's still there. I'm going to type in, instead of typing in move and then moving at a set distance, I can save my time by hitting this red arrow with gumball turned on. I can hit that red, I can click on that red arrow, and I can just type in, say, 25 feet, and it'll move it immediately. It's a lot faster. That's the whole purpose of this. If I want to build this object faster, by one step faster, I can just type in extrude curve. I could just click this, or I could just type in 10 feet. Select the object, type in cap, enter. So I've now done that in 2 moves, whereas this took 3 moves. That'll save time overall as you do a project. Now let's say I have two objects like this, and I want to, or say I have this original object and I want to remove a corner from it, and it's a three-dimensional object, right? So what I can do is I can build whatever it is that I want to remove out of it on this object. I can actually draft that by clicking Polysurface or Polyline, selecting a corner. Say I want to take 1 foot. Let's do 5 feet in this direction. Notice it says perpendicular. That is a 90-degree endpoint intersecting with that edge. So I'm going to hold it there and type in, let's take out 5 feet. And I'm using that as a reference. That perpendicular is a reference, not as a actual place where I would like to put that point at. So I'm going to do the same thing on this side here, where it's using this edge, the middle point of this edge, and the fact that it's a perpendicular. And it's doing that because I have perpendicular and middle turned on for the O snaps, object snaps for short. I'm just going to go ahead and click it there. I don't need to do a distance or anything. And then I'm going to click there again to make it a closed polyline. Now I'm going to do what we did before with this guy, but do it over here. I'm going to do it in the Y direction, where I'm going to extrude this. Extrude surface, SRF, all one word, enter. That's actually the wrong command. We'll do Extrude Curve. See, there's a very big difference there. It won't do an extrude surface if you don't have a surface to select. So you need to do Extrude Curve in this instance. Select the curve that you want to extrude. Now it says select to extrude, so it's still wanting me to select curves. We already have the curve we want, so I'm going to right click or push enter, same thing. We don't really care about how deep this is, if I want to remove all of this, I'm going to just make sure it's bigger or equal to the amount of space I want to remove. I'm going to put this into a different layer. You don't have to. I'm just going to do that just so for visual purposes, that we can tell that this is a layer that is being used for construction, or just because I prefer it. I'm going to move it over also, just so that whenever I remove this, I know that I'm not going to have a little bit hanging off. I know that I'm going to have all of this removed. Notice this, before I start removing from this object, I need to go ahead and cap this extrusion. Okay, now that I've capped that, and these are two complete 3D objects, I can remove from this one by using this object with a command called BooleanDifference, B-O-O-L-E-A-N, and then notice it has the rest typed out for me, and there's a few other commands up here like BooleanSplit and Union, which you'll also use a whole lot. BooleanDifference is one of the most highly used commands for 3D modeling. So BooleanDifference, it says select surfaces or polysurface to subtract from. So select the one you want to remove from, and then hit right click or enter. Now it says select surfaces or polysurface to subtract with. So select the one you want to subtract with, and right click or enter. And it has subtracted from that object, and we can go ahead and delete that reference polyline we made earlier. And that right there is about 90% of 3D modeling. But there are a lot of other tricks that we will dive into. Another really big chunk of it is adding three-dimensional objects together. So we can do this by, I'm going to type in move, enter, select the point from which I want to move from, and I'm going to move it over here. And I'm going to add these objects together with one command. That command is called Boolean Union, B-O-O-L-E-A-N-U-N-I-O-N. All one word, and I hit enter, and then it says select surfaces or polysurface to union. So select your two objects, hit enter or right click. Now they're one object. If I switch to a rendered view, it's just black and white rendering, and I would not use this as a render to print out and show for a studio. I would never do that. But if I show it in a rendered view, it gets rid of edges and things like that, and you can tell it is one object. And it'll always treat it as one object now. So Boolean difference and Boolean union are, like I said, about 90% of modeling in 3D modeling in Rhino. There are a bunch of other things whenever you try to do like a parametric or something really curved that come in really, really handy. Say, for instance, I have this room. Say this is going to be the outline, a plan drawing of a room that I want. And I want to make these 4 lines into walls. I can do this by extruding, Extrude Curve. Set my walls to 10 feet high, for instance. Let's just say that's a generic. I'm still in, my view setting is still in rendered. I need to switch that back to ghosted just because it's a little easier to model in. All right, so now I have 4 walls, but they have no thickness. Well, instead of going through and extruding all of these surfaces individually, I'm going to save a whole lot of time by doing all 4 at once with a command called OffsetSrf. Now, OffsetSrf is very similar to OffsetCrv. It just works on surfaces. So by hitting enter, I can select this poly surface. And then it says select poly surfaces. So we did that, so we're going to push enter. Now, notice it tells you which direction it's going to offset each surface into. We want them to, in this instance, we don't want to, we want these lines to be our perimeter and not our, not the interior perimeter, but the exterior perimeter of our walls. So we're going to extrude these inwards instead of outwards. So in order to change that, all you have to do is click on the surfaces. Sometimes it'll ask you, like, you could just do them each individually, but in this case, it just did all 4 at once, and that's very helpful. Okay, so that's all we need to do, and we're going to hit enter, and it did it to whatever distance that I had it at last time. But say I didn't like that, I can just say that was a mistake, which in my opinion was. I'm just going to hit Control-Z, and it undid everything. I'm going to retry this, so offset surface. Click on the poly surface to select it, enter, change the direction. Before I hit enter again, notice the distance is 0.125. That's probably 0.125 feet. I'm going to click on this or type in the letter D and enter. But I'm just going to click on it, and I'm going to change it to, let's say our walls want to be 4 inches thick. 4-inch sign, enter. Notice it's changed here. That's all we need to do, and hit enter. Now we have 4-inch thick walls at 10 feet high, and that, trust me, is a whole lot faster than doing each one individually and extruding them and then capping them. Okay. This command also works from curves. Say I have a curved wall. Let's do a really curvy wall. I'm going to turn off ortho in this case, and I'm going to go to my top view. Top view is the best view for drafting 2-dimensionally. Let's say we want to have a wall that looks very, very abstract or nondescript. All right, this would be a really crazy wall. I would love to see this built in real life. Actually, I could really get behind this, but let's make this a wall. Extrude curve. Let's do 8 feet Now I'm going to offset surface, and notice that it remembered the command from last time. So all I had to do was type in OF and it already knew it. I hit enter, and I'm going to select this, hit enter, and it's going to offset to the left. But let's say I really want to have it offset more of a central offset, so more of like left and right. Well, in this case, I'm going to just change our, let's say we want this to be 1 foot wide. I'm going to change the distance to 6 inches and only offset half of that foot to the left, and then I'll do it again to the right. So we've changed our distance to 6 inches or 0.5 feet, hit enter. So that's a 6-inch wall now, but we want it to be a 1 foot wall. So instead of typing in offset surface again, I'm just going to hit right click or enter, and it's going to do that command again. Since it was the last command that I did. I'm going to select that surface. This may be tricky. Yeah, let's not do that. Let's just do extrude. Extrude that curve once more. And then offset surface, select that extrusion, enter. We're going to click on it so it reverses the direction. We're still at half a foot, so we're all good. We're going to hit enter. Now we have 2 walls, or 2 objects in Rhino's eyes, both at 6 inches thick. And we're going to select both of them, type in Boolean Union, hit enter, and now it's 1 wall. So really, with a few commands, you can do just about almost anything. There's a few more things that you can do out there that are really, really crazy looking. So the curves, they look, Rhino makes it look pretty impeccable. That's one of Rhino's best aspects, is it can do curved surfaces like this, really crazy curved surfaces even. So let's say I have a series of crazy circles over here. And let's do one tiny one. Let's move these more vertically by clicking on our little gumball tool here, the blue arrow. I'll move this one 5 feet up. Move this one 15 feet up, and move this one 17 feet up. With a tool called Loft, I can select these curves in order of the direction that I want this shape to be made, and then hit enter, and then it's going to kind of verify the direction of all of these curves. This one's a little weird. I need to change this to this direction, I think. And we'll just experiment with this. Hopefully that's the right way. And we'll hit right click for enter. It'll give me a little text box saying, do you want these sections to be straight? You want to be loose? We could preview loose. You can do tight, preview that. Pan around a little bit, make sure it's the way you want it. Straight sections, it's more of an accurate overlay, but align curves. So you can kind of play around with this. Say I don't like any of these, because I really don't like the way this formed. I can actually realize that that's not going to really work very well, and I can just move this over. I'm just going to move it by maybe -2 feet this way, and -2 feet this way. And then try again. I'll do Loft, select the contour lines in their order, right click or enter, hit enter again. I like that a little more. Let's try the loose, get it a little more curvy or tight. So you notice that loose doesn't really stick to the contour as much. I can try tight, which will definitely stick to the contour. It'll hit these contours where you tell it, but in order to do that, it will also bulge where it needs to. It'll cause bulges where wherever they may be needed, and you'll get a more accurate form. I kind of like this form because it's more accurate to the lines I told it to hit. In order to really control these forms better, you just simply need more curves. You have to have more curves for it to hit, and then you would select a tight style. You could even rebuild it with more control points if you wanted to get even more control on that. So the more control points you have, the more control you have over the form. But we'll just stick to what it has, and we'll just click OK. And now we have a really crazy, wacky object here. Now, one of the big things about for studio professors, what they're going to want to see is they don't really care what your 3D objects and what you can do, what you've done in Rhino, if you can't produce drawings. So say I want to produce a drawing of something crazy like this, which I probably would not build something this crazy to begin with, because that would really, really hurt me later on. But even if I did, let's say I need a drawing of it. Say I want to do a section specifically. I'm going to draw a section right about here. I'm going to hold down Shift instead of having to go turn on ortho and having to, sacrifice that time. I'm just going to hold down Shift, which automatically turns on ortho. And then click it, let go of Shift, and then hit enter. So now I want a section of this object on that line. I can simply do this in 2 ways, which of course in this realm of thinking of using Rhino to model, in order to get your drawings, you're going to have to convert these 2-dimensional lines into a program like Illustrator and then post-produce them, which kind of, slows things down. But if that's the format you're going to go with, then go with it. You know that you're going to need some thick lines, right, for your cut line. So we can get those thick lines by typing in section, hitting enter, select the object, enter, select the line that you want to use, and notice it's already highlighting where the section cut is going to be. Right click for enter, and now you have a line for your cut line. You're going to need that, but you're also going to need other information, like what happens behind that line. I'm going to go ahead and put that cut line into another layer, a cut line layer. Let's put it in just layer 2 for now. That way it's separate from my other lines, and I can pick that up easily in Illustrator and save myself a lot of time. Let's make the rest of it. So say I want to select this object, or actually I'm going to go ahead and extrude this curve. So Extrude Curve. I'm going to bring it up here. Now I'm going to select everything and copy it, Control C, Control V, and then just drag it over. Save a lot of time instead of typing out copy. The reason why I'm going to copy is because I'm actually going to destroy this object, and I want to save my original. I'm going to destroy it by typing in trim, or actually I'm not going to do trim. Trim is more for a 2-dimensional lines. For 3D objects, you want to use a command called BooleanSplit. BooleanSplit, enter. We're going to select the surfaces or poly surfaces to split, which would be this. Enter. I'm going to select the cutting surface or poly surface. Enter. It didn't work for this one. And that's probably because this is not it's a complex object, and because it may not be capped, or for whatever other reasons. Let's try capping it. So giving it a roof and a floor, so to speak. Closing it so it's a 3D object, and we'll try it again. Boolean split, select that object, enter, cutting surface, enter. It says creating meshes, so it completed the object. Now it's two different objects. I can separate these out if I wanted. And these are closed objects now, so they are capped off, both of them. What I can do now is, having just, where are flipped upside down, there we go. Having selected this, if I want a section view of this object, I can go over to the right view. Notice it's still selected. That's the only object selected, so I don't have to get rid of, say, this guy or this one. I can just have that object selected, go to the right view, and then type in make 2D, enter. It'll have a command box. It'll ask me, what kind of things I want to keep. If I want to maintain the source layers, which I will, because say if I had like concrete, glass, aluminum, all these different source layers, all these different layers that were materials, I would want those still separate out, even though I'm making them into two-dimensional lines. That way it makes it easier to adjust all my lines in Illustrator later on, or say another program. Okay, so I'm going to tell it to maintain source layers. I don't really care about hidden lines or tangent edges in this instance. You can also, if you need to, for more technical drawings, you can do hidden lines, but for more diagrammatic, you can just go without. It's really a preference. I'm going to click OK. And notice that my drawing that I asked it to make is now at the origin of the model space, and it is flat in this view because it's the right view. But if I go to the top view, those lines have been, of this object, have been converted to a flattened drawing. I'm going to drag it over while I still have it all selected. That way it's not mixed up with our model from previous. And now I have a pretty accurate description of what's going on in this model. But before I export this, I need my cut line. So I'm going to go to perspective view. And I made this cut line earlier, right? So I'm going to select that cut line. I'm going to drag it away. And if I want to rotate it really quickly, I'm going to hold down Shift to turn on ortho, and I'm just going to rotate it off the gumball command. Gumball is so helpful for doing this. You could rotate 3D, which I will show you how to do that real quick. It would be rotate 3D. Rotate 3D is used for rotating three-dimensional objects. I would click this point, which is the origin point of the axes. I would have to click another point so that I would tell it this is the axis of which I want to pivot around. And then I could just select anywhere on this, then type in 90 degrees, enter, and see it already messed up because I didn't want it to rotate in that direction. It did it another direction of 90 degrees. Instead, I would have had to type in negative 90 degrees. See, that's one mistake that cost me time, whereas I could have just used gumball, turn on gumball, select the line, hit the arc in which I want to rotate around, type in 90, and then I can do it, hit enter again to do it again, or, well, in some instances it'll do it again. I can hit escape if I don't want to do a command, hit that arc, hit 90 again. There we go, and it's sitting upright. I'm going to place it back flat down on the ground, or on the plane, the workspace, with negative 90 on the gumball. I'm going to move it. Anytime I'm moving an object and I want it to be placed in an exact location, that's when I will type in MO or move and hit enter. Otherwise, you can just use gumball to move it around if you want to move it out of the way. But if you needed accurate placement, you needed to use move. And then I will pick a point that I know I can locate, and I will move it to where it needs to go. So now I have two lines here. I have a purple line, which in context of moving this drawing to Illustrator, I will know that my purple will be for cut lines. And I have the actual lines from the Make 2D, which Make 2D will always split curves up into many, many lines. In this instance, it's just 2 lines, but sometimes it's several little line segments. But I digress. So if I wanted to move this into Illustrator, I would select all of this. I would go to my top view, and I would make sure that it's relatively close to the origin. Since it's on this little grid, I know that it's close enough. I'm going to select Zoom Selected so that I have it all in my view. And then I'm going to go to File, Export Selected. It's going to bring up this command box. I'm going to switch this type to a Illustrator file. I'm going to type in the name. I'm going to place it just on my desktop for now. Save it. It's going to ask me the scale. I'm going to do, since this was feet, I'm going to do probably, let's say a 16th inch scale for now. Maybe I might change it to 1/8. The way I'll do that is this guy, where it says feet, that will be from this model, and this on the right side will be to the drawing in Illustrator. So I'm going to keep this at 1 inch, and I'm going to make this 16. 16 feet will be 1 inch. So 16 model feet will be 1 inch in the drawing. Preserve model scale, good. RGB, sure. Click OK. I'm going to minimize this. I'm going to open up our section drawing. Here it is. And I can easily post-produce it. I'm going to, there we go, fix that a little bit. Okay. I can easily post-produce this drawing by selecting the layer that is all of the lines that are not cut lines, and locking the layer that is cut lines. So I'm going to select all these lines that are not cut lines, make them really thin, 0.25, and then the cut lines I will make, say, 1 point. That's fine. And I will just use the standard black, change that back to 1 point. And there I have a drawing of a very strange object in section. And there are many other things, many other lines you could add to show that how this curve is actually happening. Maybe reinforce it with other drawings, like from a plan, or having those contour lines that we drew earlier drawn in on this. That absolutely is something that could be done. But this is just to show some basic 3D modeling in Rhino. Wrong one. So with these commands, you can easily build something that you would see in Studio, such as from this other project that I have from my studio. This is a topographical line drawing. These are the topo lines here. And they've been moved up to their locations by 1 foot increments. I've made this sort of surface based on that, but if you're given, say you're given topographical lines of a site, you can extrude those lines upward with the Extrude Curve command, or make planar surfaces out of them, like I have here. See, this is just all planar surfaces. These are relatively very easy to make. But once I have all of these, I can actually laser cut these surfaces out of a material, or I could 3D print them. I can do a lot of things with this information. But for a drawing's sake, I don't want to see in section, I really don't want to see something like this. You want to see a line that is accurate and it follows these contours. So in order to make that, I'm going to use a different command that I will show you now. So first I'm going to make basically what I'm going to do is I'm going to make a surface out of all of this, a curved surface that's accurate and follows these topo lines. And I'm going to do that in just the default layer for now. The way I need to do it is I need to make a little, I need to set this up a little bit first. I'm going to make a polyline that goes around the perimeter and connects to all the points, the outermost points that is. Okay, now I have this polyline that kind of roughly follows this, or accurately follows this contour. And I have these lines still, well, somewhere. I have surfaces at least. I'm going to actually bring these lines over so that I have them, because you're going to need them too. Oop, missing one. There it is. Move, or M-O-V, move, okay. I'm going to click a point that I know is going to be the same. And while I have them selected, I'm going to Control C, so copy all of them, and I'm going to undo that because I still need those lines for this drawing over here. So Control C and then Control Z, and then Control V to place them back. So that's a little thing you'll do, a little dance you'll do quite often. Whenever you realize you copied and moved, or you moved something without copying it first, you can always continue to place it, then copy it, Control Z to move it back, and then Control V to place it where you wanted it. It's a weird little dance you can do, but it's a common maneuver you're going to have to do over and over again whenever you make mistakes, and they'll happen. Now that I have the perimeter line and these model lines here, I can go ahead and make a patch. But first I'm actually going to, I realized that there was an error here where this plate didn't get made. It was not made, so I'm actually going to fix that by redoing this perimeter line. And I'm going to follow my contour lines because they are correct for sure. Errors are going to continuously happen as you're modeling. The big thing is to not let them slow you down. That is by far the most important point. This is a little weird dance I'm making here to make this endpoint really quickly. I extruded this curve out. I'm going to hit trim. If I spell it correctly, trim, enter, select my plane, enter, and then trim off that line. Now I'm going to delete this plane because I don't need it. And I'm going to delete the line that I don't need. So now I'm going to continue my little perimeter line, getting a very accurate description of this perimeter. Panning around whenever I need to. If I don't have information that I need, I can simply go and get it. So I'm going to make a 1 foot vertical line here. And the way I'm going to make it vertical is go to the right view or any view like the front view. I'll do front view. Any view that deals in verticals. I'm going to go vertical here, type in 1 foot, enter, and then enter again. Now I have a little placeholder line to tell me where to continue. And I'm going to continue my little perimeter, my little dance around the model. made a mistake here, so I will do a little command explode. Get rid of the line that I don't want. Reconnect the lines I do want by selecting, holding down Shift, and clicking on the lines I want. Might as well connect all of them that I had from before, and then I'm going to type in join. Explode and join are two commands you will also be using. So mistakes like this are helpful for tutorial videos, because then you will get a really good view of what happens when you do make a mistake, and you will also know that mistakes happen at every level, no matter how experienced you may be. Trim. I'm going to trim off this extra line that was made. Don't need him. And then I'm going to select the lines that I need to connect. Type in join. Okay, so back to the original idea is to make a accurate curved surface. We can do that by selecting this perimeter line that we made that connects all the endpoints of our topographical lines. It's sort of like a container box is what it's going to be for our surface. And then we're going to select the curves at which it will pass through. Not that one. Now I can hold down Control and deselect something by clicking on it while I hold down Control. I hold down Shift to add selections to my selection. Now that I have all those selected, I do not have any of the surfaces selected. I don't need them, just the contour lines and the perimeter line. I'm going to type in patch. It'll give me a little patch surface options box. I'm going to preview what it says here at these settings. I'm going to pan around. I'm going to zoom in tight to get a good view to make sure it's really that this surface is really following that edge, and that it's you know, it's going to be slightly off, but it's going to be as accurate as you can get it. If these settings were really like way different, it could be very, very weird looking, like all kinds of waves happening. If you have something like that, just play around with the settings. The lower the numbers are, typically means the more tight it's going to follow your contours. But the higher the numbers, you know, on stiffness at least, the higher number, like a number like 10 would be way loose, whereas 1 would be very, very tight. So if I tried 10 and I did preview, it won't show it here because our perimeter is a very good perimeter and these are not really wacky, but if I had made a mistake in the perimeter, it might actually show a whole lot of lift. You can see that there is some lift here, lift off of this perimeter line. There's probably always going to be a little bit because, quite honestly, that's how it works. It's treating this surface as a almost like a fabric, and you're telling it its characteristics right here, how stiff that fabric is. So I've changed that 10 to a 1 preview, and now it's so tight that it's trying to overcompensate. So really, we want to try and stick to something like 5. Let's try that. That's a lot closer to the middle. If I try maybe a 4 on stiffness, it's a little bit even close. I mean, it's within inches of being completely accurate, so we're good with that. Overall, everything else looks pretty good. We're going to click OK. And now we have a very accurate description of our topography. I can take that topography and the lines that we made it with, I'll just take those with it. And I can copy and paste them, move it over, work on it. 100 feet, let's just, that's not quite far enough. 200 feet, sure, that looks good enough. Okay, get it out of the way. And then now I can cut sections out of this. I can make, I really wouldn't want to, it really wouldn't matter to use this in plan, but now that the fact that I have these lines on there makes it so that I can make a plan drawing from this. This is really just something that you're going to find very helpful for also for rendering and for getting an accurate view of what's really happening with this landscape in a 3D model. All right, so that's going to end it for this video. There will be more to come on 3D modeling and making crazy stuff. Just know that commands like Boolean Union, Difference, Split, as well as offset surfaces and knowing the difference between offset surface and offset curve, extrusion commands, patch for making surfaces like this, and loft. These are really the commands you're going to use the most. There's another command I will go ahead and show real quick for making crazy surfaces that I forgot to do. It's called NetworkSrf. NetworkSrf. It's really for making curved surfaces like this one over here, but it's also good for, it's really good for if loft doesn't work or if patch doesn't work. Say you don't have all the information like these topo lines and you really want to make a good surface like this, but you have 4 edges, you can make that with NetworkSrf by typing that in, selecting the lines, and usually it'll make it, but select curves and network. Yeah, this is too flat to do it with, but yeah, I'll demonstrate that in another one. NetworkSrf is another good command to know, but yeah, pretty much anything that I've done in this video, you can use these sort of strategies you can mimic them and manipulate them to do what you want to do. That's the main point. I hope that I have shown how to do this in a way that is faster and I've shown all the shortcuts for doing them, but also getting you accurate drawings, because that's really more important than your speed. But speed's important. It gets you to sleep, and it gets your projects done in a very diligent manner. So stick around for more. There will be more videos to come. If you have any questions about something that you've encountered as far as a weird instance in modeling that you just don't know how to resolve, if you know me personally, you can reach out to me, or you could just reach out on this channel and message me in the comments below, and we can get together and figure out how to resolve that issue in modeling. And of course, and if it's a big enough issue, then we could maybe video that, show it, and others could learn from that as well. So thank you very much.